Hello everyone, welcome to Learning Academy Foundation from Mr. Andrea. Today I invite you to explore the world of programming languages and integrated development environments, or IDEs, not just as technical tools, but as instruments of creativity, precision, and purpose. Just like a painter needs brushes and a poet needs words, a programmer needs language and environments to bring ideas to life. Let's begin with the basics. Programming languages come in two main types: high level, like functional languages, general purpose scripting languages, and OOP languages, and low level, like machine language and assembly language. High level languages are closer to human language. They are easier to read, write, and understand. They include features like clear syntax, built-in functions, and probability across systems. Low-level languages, on the other hand, are closer to the machine. They give more control over hardware, but are harder to write. Their features include direct memory access, fast execution, and minimal abstraction. Some commonly used high-level languages include Python, JavaScript, Julia, Scala, Go, Java, R, Mojo, MATLAB, Kotlin, and Swift. These languages allows us to write source code, the original instruction that tells the computer what to do. This code is readable, editable, and often shared among developers to build websites, apps, and systems. At the lowest level, we find machine code, a series of binary instructions, zeros and ones, that the computer understands directly. The characteristics of lower level language machine code is a lowest level language. It's very hard for humans to understand. It's very slow to create code. There is no abstraction, so human knows exactly what's going on. Directly interacts with hardware and doesn't need translating or compiling. It is a native language of computer. Advantages of machine code are that is extremely fast execution and is just precise control over hardware. Disadvantages: difficult to write and debug, not portable across different machines, and it's hard to understand and maintain. A step above machine code is assembly language. It uses short words called opcodes, operation codes, and operands, data or memory locations. Assembly is still close to the hardware, but slightly easier to read. It's often used in embedded systems and performance-critical applications, and makes use of assembler to bring from assembly language to machine code. To bridge the gap between human-friendly code and machine execution, we use translators. That is assembler, we have seen before, compiler, and interpreter. A compiler translates the entire source code, that is human understandable code like C, CPP, Java, and so on. It finds syntax error, prompt alerts about errors and conversion before running it into a machine code. Then this understandable like OBJ or XE. So it's fast, but requires all errors to be fixed first. It's a program that converts entire source program into machine language before executing it. So from the source program goes to the compiler that has a program listing. That goes to object program that receives data. At the end, there are the results. And then we have interpreter. An interpreter translates and runs the code line by line. It's slower, but great for testing and learning. So each high-level language statement is translated, converted, and turned into machine code. Immediately executes high-level language programs, is used during build and testing, and needs to be translated every time program is executed. Let's talk about Integrated Development Environment, or IDE. An integrated development environment is like a digital workshop for programmers. The programmer skills are data structures and algorithms, database and SQL, object-oriented programming, OOP languages, integrated development environments, IDEs, cloud computing, web development, containers, text editors, and Git version control. So it brings together all the tools needed to write, test, and improve code. Key features include editors, where we write and format our code, error diagnostic and translators. These help us find mistakes and convert code into machine language. Runtime environments. It simulate how the program will run. And debugging tools that help us fix problems by showing what went wrong and where. Debugging bug refers to errors in program coding that makes the program cannot achieve the designated task. Debugging refers to the location of error and coding editing to correct the error. An integrated development environment helps us stay organized, efficient, and focused at work, just like a well-prepared classroom helps students learn better. As we explore these tools, let's remember that every line of code is a reflection of order, logic, and creativity, gifts from our Creator. Just as God designed the universe with precision and purpose, we too are called to build with integrity and care. Colossians 3:23 reminds us, whatever you do, work heartily as for the Lord and not for men. So work at it with all your heart as working for the Lord. Whether we are coding, teaching, or learning, let our work be a form of worship. If this message inspired you, I warmly invite you to like, comment, share, and subscribe to Learning Academy Foundation, where knowledge meets character and every lesson is rooted in truth and grace. Let's build a community of learners who code with clarity and live with purpose. Thank you, and may your programs run smoothly and your hearts stay aligned with God's design. See you next time. Bye.